Okay, so question number 29, redox. We're balancing redox here, and this is your equation. So we've got solid elemental iodine, okay, in solid form. We've got that mixed with a weak acid, okay, H2SO3 and water, and it produces an iodine ion plus HSO4 minus plus H plus ion. So this is what we've got. It's not balanced. It is not balanced. Now you may look and you say, oh, maybe the atoms are balanced, which I is not balanced. The issue is we can't just balance this like a regular chemical equation because it's a redox. So we have to account for the electrons, which are bound up in other elements, right? And so we have to account for all of the proper elements, the right proportions of them, to make sure that the electrons in the redox part are balanced. So we can't just simply say, oh, I2, oh, I just need to put a 2 there and move on. Can't do that. It's not going to work because we're not taking into account the electrons. So we have to do our reduction, oxidation. We want to find out which element is being oxidized, which is being reduced. So it's really easy to start with. If you have an element that's in solid form on one side and an element that's an ion on the other side, that's really easy. So this is a 0 to a -1. You see that? For iodine. So what's happening there? It is being what? Oxidized or reduced. Leo, the lion, goes grr. Okay, so it is it gaining or electrons? Gaining or losing electrons? Okay, it's actually not losing electrons. I'll tell you why. Because we're at 0 and we're going to a more negative number. So more negative number means I'm gaining negative electrons. When the actual charge goes down, it's being reduced because it's gaining electrons.
Oh yeah.
Sorry? Why would they use electrons? Or why would they lose or use? Well, because the redox is all about the electrons. So the memory thing, just remember Leo the lion goes grr. Gaining electrons is reduction. I know that seems like what's that figure of speech, English people? That's like an oxymoron. Gaining is reducing. See, I know English. Actually, don't bug me about English because I've taken way more English classes than you guys have. I've been through university, okay? I have my degree, okay? Just because I did it doesn't mean I did it well. Did you know about oxymoron? Okay? Don't turn to your neighbor either. I'm talking about the figure of speech.
What's onomatopoeia?
Onomatopoeia? That's easy. Smash! Okay, what else? Come on, bring it on. I know English. Hyperbole. That is the easiest thing I've done in a million years to tell you what a hyperbole is. Okay. Okay, so listen. I'm just well-rounded, okay? Especially in this area right here. But we need to get back to chemistry here because this is still recording. I didn't hit pause. Okay?
Can you put this on there?
Okay. Yeah, I don't really edit the video, so I don't have the time. So it's going to stay on there. Okay. So you guys can all watch this, and I'll actually have some views on one of my videos. Awesome. Okay. Back to chemistry. Why is camera? No, it's focused. Okay, so yes, I know. Finals are right around the corner. You guys are making me crazy. Okay, so this is reduction. Iodine's getting reduced. Okay, so what you do is you put I2 here, you put I minus over here, and we're going to form a reduction half reaction here. Okay, what's being oxidized then? Forget about the H's, forget about the O's. We don't count those. So let's check S, right? Now this is a weak acid. Yeah, you could split this up actually, right? Because it's aqueous. So in question 25, you remember, or 26 or whatever, they didn't split it up. Here, I think they actually do. Looking at I just glanced at the solution. I think they do split it up. So if it's an acid, weak or strong, you should split it up. So I'm going to do this, okay? I'm going to make this H plus H SO3 minus. Okay? So if it's an acid, an aqueous acid, split it up. Not a huge deal, but it's still going to all work out in the end, okay? So HSO3, so what is the oxidation state on S here? Well, each oxygen is -2, so that's -6 in total, because we have 3 of them. H is a +1 always, most of the time. And so that's a +1 there. And we have to add something in between here that equals -1 now, because it's charge. So 1 plus what? -6 gives us -1. Plus what? 4? Is that right? 4? No. 1 plus something -6 equals -1. That's tough. I'm sorry. You guys are all fried. I'm sorry. So is it 4? Is that right? 1 plus 4 is 5. -6 is -1. We're good? Okay. Sorry. This is hard for you. I understand. Okay. Yeah. I remember back in the day when it was hard for me too. Okay. So S over here now. It's +4. Sorry, you can't probably read that. It's very small. Get your glasses on. Okay. So, you don't have glasses? You should get some. Okay, so this is -2, so it's -8. So +1 has to equal -1. So what goes in here? 1 plus 7, no, it's going to be 6, yeah. It's going to be 6. Okay. So 4 to 6, so that is losing negative electrons because it's becoming more positive. Does that make sense? So it is the oxidation half. So we're going to write HSO3 minus, and that's going to turn into HSO4 minus. I mean, yeah. I think it makes sense because you have HSO3 with a -1 charge. Now you all of a sudden have HSO4 with the same charge. Something's up there, right? And so sulfur has changed its tune a little bit there. So you know something's up. Okay, let's keep going. So the steps. Identify. Now, make sure that all other elements, not including H and O, are balanced. So on the reduction half, we have a little bit of work to do there, right? There's a 2 here, and there's only 1 here. Now is where we can balance this, because we have to. So you have to put a 2 there. Okay? Got to put a 2 there. Let's complete this reduction half here. Okay, let's keep going. So after we've balanced the atoms, other than H and O, what's the next step? Should be in your notes, but you should kind of know it now. It's oxygens next, but we don't have any oxygens. It's hydrogens after oxygens. So it's oxygen, then hydrogens, then charges by adding electrons.
Since there's no oxygen or hydrogen.
No oxygens, so we'll just pass that step. Good. Hydrogens, hydrogens. Well, there's no hydrogens, right? So we don't have to balance hydrogens. So this is easy so far. Huh? No, we're on this half here. I'm still on. What did I just do? I'm still on the reduction half here.
But why do you
Why do I what?
why did you leave the one
Over here?
in the original and yeah.
Oh, don't worry about this H. This is now not a part of this species anymore. So we're just focusing on this one over here. No, we're going to account for it in the end. See, H's are over here, so we will have to add some H pluses over here. Yeah, so they'll come. They'll come just on this side. So this one here, no O's, no H's, charges. So this is a 2 minus charge in total over here, right? And this is a 0 charge. So where do I have to add electrons? Because it's reduction, this has to show a gain, right? So I have to add electrons on the left side. So I got to add 2 electrons here. And that's all you need to do to balance that reduction half reaction. Okay, we good with that? Okay. So let's move over here to the other side. So for this one, balance everything that's not H and O. Well, the S's are balanced. There's 1 on each side. Good. Let's move on. So it's the O's next, right? I've got 3 over here. I've got 4 over here. I need another O on the left side of this equation. And in order to get oxygens, we need to add water molecules. Can't just add oxygens. We have to add water molecules. So I'm going to add 1 water molecule. That will make 3 plus 1 is now 4 oxygens on the left side. Matches with 4 oxygens on the right. Got it? Okay. What do we do next, Mackenzie?
You have to balance the hydrogen.
Hydrogens. Wonderful. Okay, are they balanced? Nope, not anymore. We've got 2 plus 1 is 3. Over here we have 1. So I need 2 more. And so how do I balance the hydrogens? What do I add? Well, no, water was the oxygens. So now it's just H plus ions. And of course we need 2, right? Okay, we good? Okay, so are we done?
No.
Nope. What's wrong?
Electrons.
Thank you, electrons. So the charges here are messed up. So 2 positive plus 1 negative, that gives us a plus 1 overall charge here. And what's this over here? 0 plus negative 1 is a negative 1 charge. So I need to add electrons to one of these sides. Which side am I going to add electrons to make them equal? To the positive side. How many negatives do I have to add to this to equal this negative 1 over here? 2. Plus 2 electrons. Okay? Now, this is okay. Okay. So this is looking fairly easy. I thought 29 would be a harder one, to tell you the truth, but are we good so far? All the total charges matched up here? Okay. All right. So look at this now. We're saving ourselves a step here because just the way this works out. 2 electrons on the left side, 2 electrons on the right side. You see how we don't have to multiply any of the equations to get the same number of electrons now? So that's kind of neat, eh? Isn't that super neat? It's like teacher neat. It's not cool kid neat. But anyways, so now what we're going to do is we're going to combine the 2 equations. So I'm going to rewrite the equations here. I2 plus 2 electrons gives 2 ions. And underneath here, I'm going to put water here. HSO3 minus produces HSO4 minus plus this plus this. Okay? So I've just taken the 2 half fractions and now putting them one over top of the other. Okay? Everybody with me so far here that's wanting to be with me? Electrons, gone. Awesome. Anything else that it's identical on the same side? Doesn't appear to be, does it? Okay, so we can't cancel any more of anything else out. So we just simply go ahead and add it up, and we just rewrite now what we have. So I2 plus H2O plus HSO3 minus so on. Okay. Okay, so if you check the back of the book there, they didn't, as I mentioned before, I think I said they didn't, but they didn't split this up, which, again, if it's a weak acid, go ahead. I think it's aqueous, let's split it up. But they didn't split it up, so they actually, theirs looks a little bit different here, but no harm. Everything is accounted for here, so this is a good answer right here. Okay? Yeah. HSO4 plus, yeah. Okay? Now that's the overall net equation, and it's balanced with everything. It should be balanced in terms of elements. All elements should be balanced. All charges should be balanced. And all number of electrons should be balanced as well. So everything should be. So if we look at charges here, we have 2 minus and 2 plus cancel each other out. We have a 1 minus on this side, and I have a 1 minus on this side. See that? Good. All the elements, 2i, all the elements should be balanced. And what was the other one? Yeah, if we take a look at all of the charges or whatever, the electrons should be accounted for. Okay? You did it. I mean, we did it. I mean, mostly me. But you guys get it now, though?
Yeah.